Excuse me, sir.
Anush,
Yes, ma'am.
you Mahesh sir late ಅಂತ ಬರೋದು.
ಹಾ ಮ್ಯಾಮ್, ಅವ್ರಿಗೆ ಸಡನ್ ಕ್ಲಾಸ್ ಅಲೋಕೇಟ್ ಆಯ್ತಂತೆ, ಮಾಡ್ತಾ ಇರಿ ಬರ್ತೀನಿ ಮಧ್ಯದಲ್ಲಿ ಅಂತ ಹೇಳಿದ್ರು.
ಹೌದಾ? ಹೇಮಂತ್ ಸರ್
ಮ್ಯಾಮ್ ಇದನ್ನ ನಾನು ಆನ್ಲೈನ್
ಸರ್ ಮಾಡ್ಸೋಣವಾ?
ಮ್ಯಾಮ್ ಇಲ್ಲ, ಅವರು ಬಂದ್ಬಿಟ್ರೆ ಸರಿ.
ಹೌದಾ? ಅದೇ ನನ್ಗೆ ಇನ್ನೊಂದು ಬ್ಯಾಚ್ ಹೇಳಿದ್ರು 3:20ಗೆ. ನಾನು ಆಕ್ಚುಲಿ ಇದನ್ನ ಮುಗಿಸ್ಕೊಳ್ಳೋಣ 3:30 ಅಷ್ಟರವರೆಗೆ ಮುಗಿಸೋಣ ಅನ್ಕೊಂಡೆ. ಸರ್ ನಾನು ನೋಡ್ತೀನಿ.
ಮ್ಯಾಮ್ ಮೋಸ್ಟ್ಲಿ ಅವರು ಕ್ಲಾಸ್ ಎಷ್ಟೋ ತನಕ ಅಂತ ಹೇಳಿದ್ದಾರೆ ಗೊತ್ತಾ ನಿಮಗೆ?
ನನ್ಗೆ ಹೇಳಲಿಲ್ಲ. ಯಾವ ಅವರ್ ಹೇಳಿದ್ರು ಅನುಷ್?
ಅವ್ರಿಗೆ ಈ ಅವರ್ ಕ್ಲಾಸ್ ಇರ್ಲಿಲ್ವಂತೆ ಮ್ಯಾಮ್, ಈಗ ಅಲೋಕೇಟ್ ಮಾಡಿದ್ರು ಅಂತ ಹೇಳಿದ್ರು. Good afternoon, everyone. My name is Anush and my teammates are H. Gautam, Ashwantyu, and Gagan Raj. Today we are here to present you all about our project, Detection of Diabetic Retinopathy using Deep Learning, under the guidance of Bhavya ma'am. So now coming to the introduction of our project, first and foremost, let us know what actually the diabetic retinopathy is. It is a disease which actually occurs in a diabetic
Anush,
patient. Yes,
slide ನೋಡಿ, slide.
Yes, ma'am.
ನಂಗೆ ಬೇರೆ ಡಿಸ್ಪ್ಲೇ ಆಗ್ತದೆ.
ಹೌದಾ?
7 ಇದೆ ನನಗೆ ಸ್ಲೈಡ್ ನಂಬರ್.
Now, ma'am?
It's not showing. Only 7th frame.
Paper 1 ಅಂತ ಇದೆಯಲ್ಲ ಅದು ಬರ್ತದೆ.
Now, ma'am?
Yeah.
Yes, ma'am. So now coming to the introduction, first and foremost, let us know what actually the diabetic retinopathy is. It is a disease which usually occurs in a diabetic patient due to increase in sugar level, which finally leads to the losing of eyesight. So now why it affects only the diabetic patient is that, as we all know, that the diabetic patient blood sugar level is very high. So this sugar blocks the blood vessels, and which leads to the leaky blood vessels, and it affects the retina. These blood vessels are helpful for the vision. If these blood vessels are itself blocked by the sugar, then the person will lose the vision completely. But we can prevent this by identifying the disease at the early stage itself. Now, how will we detect this using our project is the question here. So as I told you, in our eyes there is not only the blood vessels, there is also an optic disc present in it, where the optic disc present in it. When the blood vessels are blocked by the sugar, this displaces the optic disc. Considering as a factor, we will classify it as a no diabetic retinopathy, mild diabetic retinopathy, moderate one, and a severe and a prophylactic one. Hence, this is the basic idea of our project.
After getting complete idea about diabetic retinopathy, we have come up with some objectives of our project. The first and foremost objective is to develop a complete diabetic retinopathy system to identify the presence of the disease. The identification, it can be done at different levels. That is, it could identify it at initial stage, at intermediate stage, and at the final stage. So the main objective is to come up with a complete system for diabetic retinopathy. The next objective is to detect the disease from retinal features. There are various identification methods for this diabetic retinopathy disease, but our objective is to detect it using the retinal features. The other objective is to reduce the errors of the manual system. As we know, manual system takes longer process and also has some disadvantages and also errors, and not accurate as compared to the automated system. So our next objective is to overcome the errors in the manual system. The final objective of our project is to improve the speed and accuracy. Instead of simply identifying the diabetic retinopathy disease, the accuracy and speed of this identification should be high.
Coming to the existing system, there exists early detection of diabetic retinopathy disease using machine learning, but the algorithms are used to train the model, and the CSV files for machine learning, the accuracy obtained is moderate. But the CSV file for diabetic retinopathy dataset is having less features to to train means without proper training, model cannot predict. New results accuracy is down means model does not function as well. So it will affect patient who has diabetic retinopathy. It may predict non-diabetic retinopathy and vice versa. In this case, to avoid this, we use a deep learning and CNN for training images. Data set of diabetic retinopathy, CNN yields high accuracy when compared to the machine learning. And another advantage of using CNN, it's easy to train a model. Next.
Now let's see proposed system. For the further improvement, we use a fine-tuning model like VGG16, VGG19, and MobileNet for boosting the performance of our model. We use deep learning and CNN for training the image datasets of diabetic retinopathy. The standard neural network is equivalent to a CNN. It will have a number of parameters. The training time would be also increased proportionally. Since the number of parameters drastically reduced in the CNN, the training time is also reduced and it is also easier to train the model. The accuracy of a convolution neural network is in an image recognition problem. CNN are found to have a better accuracy means compared to other classification techniques, so it is more desirable while using CNN. Moving on to the literature survey.
So now coming up to the literature survey, as we already told you about the basic idea of our project, after initial study, the 5 main features from which the disease could be identified. Based on these features, we started our literature survey. Yes, so moving on to the first paper, it is a base paper. The title of the project is Diabetic Retinopathy Detection Using VGG, a Deep Learning Architecture, and the following are the authors. It was published in the year 2021. From this paper, we came to know what actually the diabetic retinopathy is and the main cause of it. And the main cause is the damage of blood vessels, which leads to the blindness. This paper mainly focuses on classifying the disease into different stages by applying the methods like VGG16, VGG9, like that. The stages are no diabetic retinopathy, moderate, mild, severe, and prophylactic diabetic retinopathy, which leads to the deep learning model called VGG model. According to the VGG model, the DR model scales it and makes the classification. And this method has more accuracy when compared to other model. So then coming up to the next paper, and this which refer to the and the title of the project is blood vessel segmentation of fundus image by major vessel extraction and the sub-image classification. And the following are the authors, and it was published in the year 2030. From this paper, we got to know how the segmentation of blood vessels can be done from the fundus images. The fundus images are nothing but the photos of interior eye through the pupil. Here, they have used an Gaussian mixture model and also the pixel-based classification. And we got to know that the algorithm is less dependent on training data, so the segmentation time could be less. And these are the things we got to know from this paper.
Now let us look into the next paper, that is machine learning based automation neovascularization detection on optic disc region, which was published in the year 2017, and the following are the authors of this paper. From this paper, our main objective is to detect neovascularization in optic disc region for color fundus retinal image. Therefore, the importance of accurate and timely detection of neovascularization cannot be underestimated. In this paper, they have used support vector machine methodology for the detection. The author proposes an automatic image processing procedure for neovascularization detection, which includes feature extraction, feature selection, and machine learning classification. The proposed algorithm achieves high sensitivity on both training set and test set. The future work of this research will expand to neovascularization elsewhere detection, which is challenging because of the existence of low vessel contrast. Now let us move on to the next paper. The next paper is Exudate Detection for Diabetic Retinopathy with Convolution Neural Networks, which was published in the year 2017 in the International Conference of Global Prevalence of Diabetes by the following authors. In this paper, deep convolution neural network is adopted to achieve pixel-wise exudate identification. So, to achieve this pixel-wise accuracy, meanwhile, to reduce computing time, potential exudate points are first extracted with opening algorithm. The methodology used to achieve this task is deep learning. The method achieves a high pixel-wise accuracy for training set and test set. The future work of this research can involve testing methods on more publicly available databases. Due to the nature of machine learning and deep learning, increasing data quantity and variation will lead to the improvement of model performance. Moving on to next paper.
Let us look into the next paper. Automatic detection of diabetic eye disease through deep learning using fundus image, a survey, which was published in the year 2020, and following are the authors. From this paper, we came to know the present systematic automated approaches to diabetic eye disease detection from several aspects. The survey provides a comprehensive synopsis of diabetic eye disease detection approaches. In this paper, they have used deep learning methodology, and initially a keyword search was conducted using 10 academic databases. Considering our specific review target, 7 filters were applied to select a primary review target. The review paper provides a comprehensive overview of state on the diabetic eye disease detection methods. Next, moving on to the paper 6. In this paper, the title is the optic disc detection in fundus images based on structured learning, which was published on the year 2017, and following are the authors. In this paper, author proposes an algorithm for optic disc detection based on structured learning. A classifier model is we use the model to achieve edge of the optic disc. And in this paper, they have used the random forest methodology for detection. The proposed method in this paper employs structured learning to capture the optic disc edge information because the proposed algorithm belongs to the supervised methods. The trained edge detection plays an important role in performance of proposed system. Moving on to next paper.
This is another paper which is referred to our project, and the title of a paper is Detection of Retinal Microaneurysms Using Fractal Analysis and Feature Extraction Technique. This paper was published on year 2013. From this paper, we get to know how microaneurysms in the retinals are detected. In this paper, a novel method is used for the improvement in the detection of microaneurysms using the fundus images. On screening, it detects the small red dots on the retinal fund images that gives the earliest possible sign of the disease. In this, the proposed algorithm in this paper are consistent using two stages. The first stage is consisting of image processing and fractal analysis of a retinal structure. And the second stage aims at the detection of typical shape of a microaneurysms has an abnormal retinal image that goes through canal edge detection and morphological reconstructions. This implemented algorithm is achieved a best operating sensitivity and a specificity, which makes it feasible for detecting diabetic retinopathy. Moving on to the next paper. This is another paper which is used in our project. The title of a paper is Dynamic Thresholding Technique for Detecting Hemorrhages in Retinal Images. And this paper was published in the year 2014. The algorithm used in this paper is based on the color and size of the hemorrhages as a tool for classifying hemorrhages from the other dark lesion part in the retinal images. In this algorithm also uses the concept of contrast enhancement, background estimation, and intensity variation at edges that is supposed to be some morphological operation. In this approach is done by step-by-step removal of unwanted features in the images. This method also uses a green channel extraction and grayscale conversion of an image. This method also effectively application to be used in a diabetic tool for identification hemorrhages for diabetic retinopathy detection. This paper includes that hemorrhages are detected at good accuracy and fast in execution using the retinal images. This paper can be enhanced by the algorithm classifying in the data images into a mild, severe, and moderate by obtaining features from the extracted hemorrhages. Moving on to the literature survey findings. Presently, deep learning models are effectively used in the image for classification, detection, and segmentation and pre-processing. We can infer that CNN is currently the most preferred deep neural network, particularly for the detection of eye disease, as well as the diagnosis of other pathological indications for the medical images. We have noticed that deep learning performed well on binary classification tasks, whereas it performed significantly dropped when the number of classes increased. The study reveals the research gap from more rigorous approaches to be development of multi-classes classification problem. Furthermore, we have observed that the binary classification is mostly conducted between the normal and affected cases. Deep learning has shown an extensive capacity in the field of healthcare and especially in the field of eye disease detection.
It's not audible. Yeah.
Oh, sorry, sir. So according to our analyzation, we have come up with the initial design with this way. In the first stage, we will collect the images having no diabetic retinopathy, severe, mild, moderate, and prophylactic diabetic retinopathy images. After that, in the next stage, comes the pre-processing stage where the noise of the image is cleared and the resizing of the imaging is done in OpenCV, and finally the images is divided into train and test data. Now after splitting the data, we apply the deep learning methods like CNN, VGG16 or VGG19, DenserNet. We will validate the test data, and finally the test data is built. Once the model is ready, we will input a new image that is not in train and test data. Now the predictions start, and it classifies the images as the following: mild, high, moderate, severe, no. And finally the accuracy is given as an output. And this is the initial design of a project. And these are the references which we where we found the paper. Thank you. Sir, any inputs or suggestions?
Okay, so the presentation was good. At this stage, so I think you have done the required work. So I have a few basic questions like why you are going with a deep learning? Why not machine learning?
Yes, sir. In machine learning, like we have to use only the CSV file or the features. Features are, it is difficult to train the model, sir. For each features, we have to go through separate models, sir. Like for blood vessels. For blood vessel segmentation, different algorithm we have to use, and for we have 5 features basically. For each thing we have to use different models, and for the large data set it is not suitable, sir. Machine learning, in deep learning it will be performed very well. That too for an medical images, it will be very fine. So we have thought to do it in a deep learning models.
Okay. So, can you add something for your product? Of course, your project was good actually. Project is good actually. Is it how exactly your output will be visible to the people? I mean, how exactly your model will be?
Yes, sir. Yes, sir. Means we are thinking to build an interface, front-end interface, a simple one, not an complex,
Hmm.
where we
Okay.
where the images is inputted. Image, like an it's an what? Wait, sir. I will find it in a BPD itself. Like fundus image. Oh, I have not put it in, sir. The sample image will be given, sir. Fundus image. It's an fundus image is nothing but the interior image of an eye that will be given as an input, sir. The image can have the disease or may not have the disease. Based on the features, it will be identifying whether the image has an high, moderate, or severe one, or no diabetic retinopathy. And
Okay, based
pop-ups
on the
will be
percentage.
yes, sir. Based on the accuracy percentage, it will be given, sir. For high, if it like 18%, and for mild 70%, it will consider for a mild and giving it an accuracy as a mild diabetic retinopathy.
Okay, fine. Okay,
We
fine,
have
I
Anish.
thought
have
to
few more
yes,
questions.
sir.
If I can
Yes,
ask.
yes, sir. Yes.
How exactly you will distinguish it is diabetic retinopathy and not other possibilities? Because the blood vessels may be damaged because of various reasons. Okay, so even a small blood clot or
Yes,
many
sir.
other diseases may damage the blood vessels. Can you tell us what are the prominent features which can help us distinguish between diabetic retinopathy and other diseases?
Sir, not only the blood vessels, but also the other features like an optic disc displacement and hemorrhageous detection. And taking all that consideration, we will not give, sir, not only the
And the
blood
same
vessels.
can happen in other diseases also. Okay. As you mentioned, changes in maybe the shape of the lens,
Yes, sir.
and also whatever features you mentioned. To my
Yes, sir.
understanding, it can happen even in other diseases. So there should be something different in diabetic retinopathy, which can be used to very clearly identify, yes, it is diabetic retinopathy and not any other XYZ disease. So what is that prominent feature? I just wanted to know.
That prominent feature will be like.
Okay, it's okay. If you do not know the answer, you can search for it.
No, sir. One
Because how
thing I
you
heard.
identify the region of interest in an image? Okay.
Yes,
So
sir.
considering it may be a diabetic, retinopathic image or a normal, whatever it is, how
Yes,
region
sir.
of interest will be identified?
So we use some smoothing techniques or filtering techniques to identify the region of where we want to match the image, that telling of if it is blood vessels or hemorrhages detection or
And now at this stage, you need to be clear. After doing literature survey, you should have decided. So what are the techniques, methods you will be using to maybe remove the noise in the image, identify the ROI, region of interest, how to deal with it. ಅದೆಲ್ಲ ಒಂದು ಕ್ಲಾರಿಟಿ ಅಚೀವ್ ಆಗಿರ್ಬೇಕು ನಿಮಗೆ after doing a detailed literature review.
yes sir.
If you have knowledge about it, you can present. If not, definitely you can get back with all the details.
Yes sir.
Once again, you have classified it into mild, high, moderate. These are the different stages ಅಂತ ಹೇಳಿದ್ರಿ ಅಲ್ವಾ?
Yes,
sir.
sir.
Once again, can you tell us the difference between stage 1, stage 2, which is once again mild, high, moderate? What things will distinguish these stages? Like what I mean is from mild to maybe moderate, moderate to severe, severe to high, athwa no diabetic retinopathy. What features or what observations can make this decision?
So if we take the nervous system in the eye, if there is no any disease, if there is no effect, there will be no improvement or extra cell or extra muscles growth in the nerves or in the eye. If we take severe, we are using the blood vessel segmentation, exudates, and hemorrhages detection, microaneurysm detection. They have some like exudate. If we take exudates in the nervous system, there will be a white patches for the starting stage and dark yellow patches if it is severe, sir.
And one more thing I would like to add up, sir, like from what amount of displacement of optic disc is done, and blood vessel at how much it is blocked. If it is blocked, then the nerve will be bigger one. Based on that, we'll be classifying it as high, moderate, like that, sir.
Okay, so already we have many deep learning approaches to once again do the same. ನೀವು ಏನು claim ಮಾಡ್ತಿದ್ದೀರಾ ಅಲ್ಲಿ? So already many projects are available. Okay, so which is doing the same. So taking a diabetic retinopathic images and trying to classify it, and even predict the occurrence of diabetic retinopathy in the future. So already we have models which are doing this, and how your application or project is different from what is already available so in internet. So do you have any innovative mechanisms or something that will distinguish your project with what is already available?
Sir, in deep learning, not only one algorithm is available, sir, like different algorithms like VGG16, TensorNet, VGG19, like not in existing. We'll be implementing.
For your information,
Yes,
one minute, Ankush alva?
Anush, sir.
Anush, sorry. So the same project has been done by your seniors. Last year, ಮಾಡಿದ್ದಾರೆ, you can check the report. They have used the same. ಇಲ್ಲ ಇದೆ report ನಮ್ಮ lab ಅಲ್ಲಿ ನೋಡಬಹುದು.
Yes, sir.
So they have used the same mechanisms. Whatever you mentioned, same thing is used, same outcome, but I did not see any improvement or maybe any difference. You can go and check last year, and even in 2020, meaning that 2 years back also this project was done, but they had done some improvements or what was already existing. I do not exactly remember what were the improvements or how they had expanded it, but they had done it. That is what I remember, because of which an approval was given to them and they were allowed to proceed. ನಿಮ್ದು ಏನು ಏನು ಇಂಪ್ರೂವ್ಮೆಂಟ್ಸ್ ಅಂತ ಏನೋ ಕಾಣಿಸ್ತಿಲ್ಲ, ಕ್ಲಿಯರ್ ಆಗಿಲ್ಲ.
Sir, they have done for the different project, like different disease, sir. And algorithm is also different, sir.
Anyhow, the data is available. ನಿಮಗೆ share ಮಾಡಿದ್ರೆ projects done in 2020, meaning that 2 years
Yes,
back,
sir.
and
Yes, sir.
also
We
projects
have
done
gone
during
through
the
it.
previous year. So you can see in both the years they have done this project. Okay, so detecting diabetic retinopathy.
ಸರ್ ಅದೇ ಇವರು ಇದು ಡಯಾಬಿಟಿಕ್ ರೆಟಿನೋಪತಿ ಮೇಲೆ ಮಾಡ್ತಿರೋದು, ಅದ್ ಮುಂಚೆ ಇದ್ದಿದ್ದು ಬೇರೆದ್ದು ಗ್ಲುಕೋಮನ್
ಇಲ್ಲ
ಅಂತ
ಮ್ಯಾಮ್, ಇದನ್ನೇ ಮಾಡಿದ್ದಾರೆ. ಲಾಸ್ಟ್ ಇಯರ್ ಮಾಡಿದ್ದಾರೆ ಮ್ಯಾಮ್, ಡಯಾಬಿಟಿಕ್ ರೆಟಿನೋಪತಿನೇ ಮಾಡಿದ್ದಾರೆ. 2 years ಇಂದಾನು ಮಾಡಿದ್ದಾರೆ ಪ್ರಾಜೆಕ್ಟ್.
ಹೌದಾ? ಓಕೆ, ನನ್ಗೆ ಇದು ಗ್ಲುಕೋಮನ್ ಅಂತ ಬರುತ್ತಲ್ಲ, ಐದೇನೆ ಅದನ್ನು ಪ್ರಾಬ್ಲಮ್. ಅದ್ ಮಾಡಿದ್ದು ಹರ್ಷಿತ್ ಅವ್ರ ಟೀಮ್. ನಾನು ಇದು ಡಯಾಬಿಟಿಕ್ ರೆಟಿನೋಪತಿ ಬೇರೆ ಡೇಟಾ ಸೆಟ್ಸ್ ಹಾಕಿ ಟ್ರೈ ಮಾಡಿ ಮತ್ತೆ ಅಲ್ಗೋರಿದಮ್ ಚೇಂಜ್ ಮಾಡಿ ಅಂತ ನಾ ಹೇಳಿದ್ದೆ, ಸಜೆಷನ್ ಕೊಟ್ಟಿದ್ದೆ.
2020 ಬ್ಯಾಚಲ್ಲಿ ಮಾಡಿದ್ದಾರೆ ಡಯಾಬಿಟಿಕ್ ರೆಟಿನೋಪತಿ. ಇಲ್ಲ ನಮ್ಮ ಪ್ರಾಜೆಕ್ಟ್ ಲೆವೆಲ್ ಪೋಸ್ಟರ್ ಇದೆ ಅದು. ಹೌದು, ಒಂದ್ಸತಿ ನೋಡೋಣ, ಚೆಕ್ ಮಾಡೋಣ. If it is, if they are just repeating what is already done, we will ensure that they
ಇಲ್ಲ ಇಂಪ್ರೂವ್ಮೆಂಟ್ಸ್ ಹೇಳೋಣ.
ಇಂಪ್ರೂವ್ಮೆಂಟ್ಸ್ ಖಂಡಿತ ಮಾಡಿಸೋಣ.
Okay.
Anyhow, the preparation was good. Presentation was really convincing. But whatever aspects were mentioned, I think you need to dig deep into it and you need to give the required clarity at this stage. Okay, ma'am. That was from my side.
Okay. Okay, sir. ಅನುಷ್
Yes, ma'am.
ಅನುಷ್ and team. ಅದ ಇನ್ನ ಸ್ವಲ್ಪ ನೀವು ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಡೀಪ್ ಆಗಿ ಹೋಗ್ಬೇಕು ಆಕ್ಚುಲಿ ದ ರೆಟಿನೋಪತಿ is and how actually it is causing for only for diabetic patient and what is the different types of causes for other patients, that also you need to check. Nervous system ಗೆ ಓನ್ಲಿ ಹಿಂಗೆ ಡಯಾಬಿಟಿಸ್ ಗೆ ಹೀಗಾಗುತ್ತಾ ಅಥವಾ ಬೇರೆದಕ್ಕೂ ಆಗುತ್ತಾ, such kind of differences you should note. ಇನ್ನೊಂದಷ್ಟು ಏನ್ ಮಾಡಿದ್ರೆ ನೀವು ಅದನ್ನ ಸ್ವಲ್ಪ ಇನ್ನ ಕ್ಲಿಯರ್ ಆಗಿ ಓದಿದ್ರೆ ಯು ವಿಲ್ ಬಿ ನೋಯಿಂಗ್ ಕಂಪ್ಲೀಟ್ಲಿ. ಅದೆಲ್ಲ ಸರಿ ಇದೆ, ಕರೆಕ್ಟ್. ನೀವು ಏನ್ ಪ್ರೆಸೆಂಟ್ ಮಾಡ್ರಿ ಅದೆಲ್ಲ ಕರೆಕ್ಟ್, ಬಟ್ ಮೆಡಿಕಲ್ ಟರ್ಮ್ಸ್ ಯು ಶುಡ್ ನೋ ಸ್ಟಿಲ್ ಸಮಥಿಂಗ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್ ರಿಲೇಟೆಡ್ ಟು ಯುವರ್ ಮೆಡಿಕಲ್ ಫೀಲ್ಡ್. ಇನ್ನ ಒಂದಷ್ಟು ಇಂಪ್ರೂವ್ಮೆಂಟ್ಸ್ ಆಗ್ಬೇಕಷ್ಟೇ.
Yes, ma'am, we will go through it.
You go through the medical papers also.
Yes, ma'am, we will go through
Medical research
We'll check
papers.
it out.
Yeah.
Yes, ma'am.
Thank you. Thank you. You can wind up the session.